linear momentum. All the material, they got the mass. So all the mass are the center of mass is all the they are all the particles, they are the weight. Their weights are collected at the starting point. So then we will center of the mass. Center of mass is this is the momentum here. This is the many particles. Particles so before this one is a force 1, this is a force 2, force 3 like this. All the combination of force, the F2 there is a F1 plus F2 plus F3. So the all combination of force are they are passing through at the starting point. So this point, so this is the F2 there. This two there we call it this is center of mass. Center of mass or center of gravity. Center of mass or the center of gravity. So this is the way that we can calculate center of mass. So when you calculate the center of mass, we can use the momentum. So this is F1, this is H1. F2, this is H2. F3, this is H3. Okay, here we the FT. So this is HT. So we can calculate FT multiplied this HT is equal to F1 H1 plus F2 H2 plus F3 H3. So we can calculate HT is equal to F1 H1 plus F2 H2 plus F3 H3 divided by F2 there. So F2 there is here we can calculate F2 there is F1 plus F2 plus F3 and therefore the HT can be calculated F1 H1 plus F2 H2 plus F3 H3 divided by F1 plus F2 plus F3. So this is the F is a force. So F is equal to mass multiplying G. So in this case N is the mass, G is a gravity. So in this case F1 is N1G1, N1G, F2 is N2G, F3 is N3G. So the H2 there can be calculated. N1 is N1G, H1 plus F2 is N2G, H2 plus F3 is N3G, H3. And divided by the F1 is N1G, F2 is N2G, F3 is N3G. So that we calculate so G taken out, so the H2 that can be calculated N1 H1 plus N2 H2 plus N3 H3 divided by the N1 plus N2 plus N3. So this H2 there we also call it center of mass. So all the equipment are the combination of the small particles. They can be divided into the small particles. Each particle got the weight, each particle got the mass. So the combination of the all weight and all mass are passing through the starting point. This is the center of mass or the center of gravity. So the center of mass or center of gravity can be calculated. H2 there is F1 H1 plus F2 H2 plus F3 H3 divided by F1 plus F2 plus F3. Or N1 H1 plus N2 H2 plus N3 H3 divided by N1 plus N2 plus N3. So therefore we can calculate H2 there. Summation of F8 divided by summation of F or summation of M8 divided by summation of M. So that's the way we calculate for the center of mass or center of gravity. Okay, so three particles masses are N1 1.2 kg, M2s are 2.5 kg, and M3 3.4 kg. They work the equilibrium cycle. So measure 140 centimeter. So this one will be this is the cycle here. So this is 140 centimeter. So this is 140, and this is 140. So this is the equilibrium triangle. So in this case, N1 is 1.2 kg. So we have to draw a coordinate line. So this is the y-axis. This is the a-axis. Here is N1. M1, M2, and the M3. So we can find out the distance. M1 coordinate. So M1 is a 1.2 kg. The coordinate is a 0, 0. And M2 is a 2.5 kg. And coordinate is a 140 and 0. M3 is a 3.4 kg. Coordinate is the horizontal coordinate is 17 and vertical. Vertical you can find out the coordinate. So that will be also the vertical coordinate is we can calculate. So this vertical coordinate this is for A3, Y3. So Y3 can be calculated. Square root of 140 square minus 70 square. So that will be 120. So Y3 is 120. So that this one will be calculated at Y3 is 120. Okay, so we have to calculate the H student. So in this case, N1 H1 plus N2 H2 plus N3 H3 divided by N1 plus N2 plus N3. So the N1 will be 1.2 into 0 plus N2 255 in 140 plus N3 3.4 into 70 divided by 1.2 plus 2.5 plus 3.4. So by solving this one, H total we got is 83 centimeter. And also the Y total we calculate N1 Y1 plus N2 Y2 plus N3 Y3 divided by N1 plus N2 plus N3. So we calculate N1 will be 1.2 into Y1. Y1 is 0. N2 is 2.5. So then into also 0. N3 is 3.4 into 120. So divided by 1.2 plus 2.5 plus 3.4. And therefore the Y total can be calculated as 58 centimeter. So this is the way that we calculate the center of the gravity, center of mass for those equilibrium types. For the three weights, they are located in the side or corner of the equilibrium triangle. So this is for the uniform mass metal plate. The two are from which the gist of the radius are. In this case, R has been set out. So use the xy coordinate and locate the center of mass of the plate. In this case, when you are they are surface element, you can combine together. For this distance, you have to remote. You have to remote means you have to eliminate. So in this case, we can take out the center of mass. For example, here is the xy plane. So for this one with the area A1, and this is the area A2. So A1 can be calculated. A1 is the whole circle. The radius is pi into radius square. So radius square, so this is the whole A1. And also the mass. A1 multiply density, rho is a density. So therefore the area is pi into radius is 2r, the whole square into rho. So there will be pi into 4r square into rho. So this is for the radius. In the meantime, H1 is the center point is 0. And also it's Y1 is also 0. So this is for the area. In the meantime, we also can calculate. So A2. So this is the area A2. A2 is a pi into radius square. So pi into radius square, we can calculate. So in this case, how to calculate the radius square? So then we just pi multiply radius. Radius will be r square. R square means pi r square. So the M2. So A2 multiply rho. So we have density, so pi r square into rho. So this is the M2. So for the M2, this is for H2. This is H2. H2 is located at minus R. So H2 is a minus R, and also is Y2 is equal to the 0. Okay, so then you can calculate HT. So this is a N1 H1 plus and in this case you have to subtract because of this one is a N1 H1 minus N2 H2 divided by this N1 minus N2 because we are set out means that you have to subtract. So in this case we calculate N1 H1 minus 1 is a pi into 4r square into rho and the H1 is a 0 minus M2 is a pi into r square into rho. H2 is a minus r. Okay. And N1 minus N2. N1 minus N2 is a N1 is a pi into 4r square into rho minus M2. So pi into r square into rho. So we got. So by solving this one, what you call it, this one 0 to the minus is a positive. So pi r2 into rho, and the denominator is a pi 4r square into rho and pi r square into rho. So this is a 3 pi r square into rho. So this is what we can say. So what you call it, r by 3. R by 3. So this is center of the mass we located at the r by 3. So this is the center of mass. In the meantime, YT also can calculate it. So then we use N1 Y1 minus N2 Y2 divided by N1 minus N2. So the N1s we calculate N1 value is a pi into 4r square into rho minus N2. N2 is a pi into r square into rho. So the rho in the Y1 is a 0 minus pi into r square into rho into 0 divided by pi into 4r square into rho minus pi into the r square into rho. So this is the numerator is 0 and denominator is 3 pi r square into rho. So this is also 0. So the center of gravity is located. This is the r by 3 and 0. So this is the center of gravity 1. Center of mass 5. R by 3 and 0. So this is the center of mass 5. This is for the 3 forces. The F1 is 6 Newton and 4 kg. F2 is 12 Newton and 8 kg. F3 is 14 Newton and 4 kg. They are acting. So we have to find the transformation of the center of mass system. So in this case, you have to find the center of mass transformation. So the F2 can be calculated. F2 is so summation of F we assume that this direction is positive and this direction is negative. So in this case, so this is this direction F1 is minus 6 plus this direction. So F2 cos 45 plus that direction F3. So in this case, minus 6 plus F2 is 8 into cos 45 plus 14. So by this way, you can calculate for the F total. So summation of F can calculate minus 6 plus F2 cos 45, so 8 into cos 45 plus 14. So this is the summation of the F8. So this is F18. This is for the F18 plus F28 component plus F38 component. So F18 is the minus 6 horizontally. F28 is F2 into cos 45. So this one, this resource is the 2 component. And F38 is 14. So then we get 13.65 Newton. So this is F8. So we also have to calculate the 8. 8 can be calculated. So in this case, what is the direction? What is the acceleration of the center of mass? So this is for the F1 F8 we can calculate 13.65 Newton. And another one is Fy. Okay, Fy also calculate. So Fy is also the summation of Fy. In this case, this direction is a positive, this direction is a negative. So in this case, summation of Fy is equal to F1y plus F2y plus F3y. So the F1y is a horizontal length, so this is a no y component, so 0. F2y is a, you can calculate F2 into the sine 45, F2 sine 45, F3y also 0. So therefore the F2y is a F2 value you calculate the 12 into sine 45. So then we will have 12 multiply the sine 45, or this is for the 12. 12 multiply sine 45. And y is equal to the 12 multiply so this is a 8 points are 4 Newton. So this is for F8 and the Fy we calculate. Okay, so F8 is so the summation of F8. So in this case you can calculate the F total. F total is a square root of F8 square plus F1 square. So there is a F8 square with the 16.48 square plus F1 is a 8.48 square. So that will be the 16.48 square plus 8.48 square. Then square root, so 18.53. So this is the F total. So the F is equal to MC into acceleration. So the 18.53 Newton. So the mass you can calculate M1 plus M2 plus M3, and the total acceleration is 80. So the 18.53 is the M1 plus M2 plus M3. M1 will be 4, M2 is 8, M3 is also 4 into A total. So this 18.53. So this is for the 15 into A total. So A total is 18.53 divided by 15. Divided by 15, so that will be 1.158. So meter per second square. So this is for the acceleration of the center of mass. And also we also need to find the direction. Direction means you have to find the HD and the YD. So H total can be calculated. So in this case, H total is F1 Y1 plus F2 H2 plus F3 H3 divided by F1 plus F2 plus F3. Okay, so F1. So right direction positive, left direction and negative. So in this case, F1 is minus 6, H1 is original 8, minus 2. So this is minus 2. Plus F2 is 12 cos 45. Original direction is 4. Plus F3 is 14. Original direction is we can say 1. Divided by the F1, so F1 is minus 6. Plus F2 is 12 cos 45. Plus F3 is 14. So this will be 12 plus 12 into cos 45. 12 cos 45 will be calculated, so this is 8.48. And F3 is 14 into 1. So this is 14. Divided by minus 6 plus 8.48 plus 14. So this will be solved. So this is for the 12 plus 8.48 plus 14. So there will be the numerator is 34.48. And denominator 8.48 minus 6 plus 14. So that will be 16.48. So the H direction will be 34.48 divided by 16.48. So this is 2.09. Similarly, you can also calculate as a y total. Y total is F1 y1 plus F2 y2 plus F3 y3 divided by F1 plus F2 plus F3. Okay, so horizontally F1 y1. So in this case F1 horizontal component. So F1 H. So in this case, vertical component. So this is the F1 H1, F2 H1, F3 H1. Here is the F1 Y1, F2 Y1, F3 Y1 divided by F1 Y, F2 Y, and F3 Y. So Y component of F1, Y component of F2, Y component of the F3. So in this case, Y component of F1 is 0. A is 3. Y component of the F2. This is 12 sine 45. And also the Y component of this is 2. F3 Y component is also 0. Y3 is minus 2. Divided by F1 Y component is 0. 12 sine 45 also 0. So that way this is what you got to say is 12 sine 45 into 2 divided by 12 sine 45. So this is a 2. So the direction you can also calculate. So H is a 2.09, Y is equal to 2. So the direction theta, tangent inverse Y by 8. So tangent inverse Y is 2 divided by 2.09. So tangent inverse 2 divided by 2.09. So you got the thing at 0.956. So we find the inverse tangent. Inverse of tangent 0.956. That will be 43.7 degrees. So this is for the direction. Direction of mass we can calculate by this way. Rotation means the rotation is angular velocity. So this is the position to move from the angular is a rotation. This is original position here, and this one passing through the angle theta. So this is passing through the circle plane S. So this is the angular rotation. So in this case, I is a radius, and A is a circle plane. So angular path. So the point the object is originally at the position 1, and they passing through the circular path S, and then reach the position 2. That way is a rotation. So in this case, every one revolution is a 2 by radian. One revolution is a 360 degrees, so this is 2 by radian. Therefore, the 1 radian is a 1 divided by 2 pi. So 0 pi is 159 revolution. So 1 radian is about 0 pi 159 revolution. So we can write down the angle. Angle will be angular velocity. Angular velocity is omega. This can be calculated. Change the angle divided by change the side. So this becomes the final position at theta 2 minus original position theta 1 and T2 minus T1. So this is the way that we can calculate with angular velocity. And therefore the angular velocity is the change of the angular angle divided by the side began to the change the angle. So this is the way we calculate the angular velocity. And in the meantime, we can also calculate the final velocity. Final velocity, W2 is equal to initial velocity W1 plus Fi into theta t. In this case, Fi is the angular acceleration. So W is the angular velocity. So Fi is the angular acceleration. So angular velocity is radian per second. Angular acceleration is radian per second square. Okay, so F also calculate W2 minus W1 divided by T. So this is angular acceleration. And also we can calculate the angular displacement. Is equal to W1 d plus pasta alpha d squared. So angular displacement can also be calculated by this formula. Problem. So the d is a moving. The moving along the reference line is given at this equation. Theta is a minus 1 minus 0.6 d plus 0.25 d squared. So we have to grab the angular position of the disk versus side. So for the we have to plot the graph from the minus 3 to 5.4 seconds. Okay, so this one is a minus 3 to 5.4 seconds. You can substitute. So this is a theta minus 3 is equal to the minus 1 minus 0.6 into minus 3 plus 0.25 into the minus 3 squared. So you substitute and you solve. And also similarly the minus 2 minus 1 minus 0.6 into minus 2 plus 0.25 into minus 2 squared. And minus 1 minus 0.6 into minus 1 plus 0.25 into minus 1 squared. And a 0 minus 1 minus 0.6 into 0 plus 0.25 into 0 squared. And then we can calculate for the 5.4. So by this way you can substitute and then you got the 5.4. And then you can plot the graph. Plot the graph means horizon is t and vertical is theta. Then you can plot the graph like this. So this is for the part A. Which is just a theta reach the maximum value. So in this case, minimum value is equal to the d theta by dt is equal to 0. And you have to find a t. Therefore, we have to differentiate. So theta is equal to given as minus 1 minus 0.6 t plus 0.25 into t squared. Therefore, we differentiate the d theta by dt. So d by dt minus 1 minus d by dt 0.6 t plus d by dt 0.25 t squared. So therefore, then you can calculate the d theta by dt. So d by dt minus 1 is equal to 0. D by dt is 0.6 is minus 0.6 and plus d by dt 0.25 is 0.25 into 2 e power 2 minus 1. So therefore, the d by dt is equal to minus 0.6 plus 0.5 t. So d by dt is 0, so minus 0.6 plus 0.5 t. So 0.5 t is equal to 0.6. So t is equal to 0.6 divided by 0.5. So this is equal to 1.2 seconds. And then you can calculate the theta. The theta formula you can calculate with substitute here. Minus 1 minus 0.6 t plus 0.25 t squared. So minus 1 minus 0.6 into 1.2 plus 0.25 into 1.2 squared. And by this way, you got the angle theta. Angle theta value we can calculate, and that will be this is always a 77.9 minus 77.9 degree. So in this case, theta partially we calculate the radian. So this is a minus 1/36 radian. In this case, 180 degree is a pi radian. Therefore, the pi is a 3.14 radian is equal to 180 degree. So the minus of 1/36, how many degree? So 180 into minus 1/36 divided by 3.14. And therefore, we can calculate the angle. Degree will be minus 77.9 degree. This is the way we can calculate for the angular side, angular movement. So this is for the crime show. The constant angular acceleration alpha is 0.35 radian per second square. Time t equal to 0, angular velocity omega 0 is minus 4/6 radian per second. So when you calculate f1 times after t0 is reference line at the angular velocity theta equal to 5 revolution per second. So in this case, this is the 5 revolution. Theta 0, original theta 0 is 0. And final theta is equal to the 5 revolution. So one revolution is a 2 pi radian. So this is a 10 pi radian. So we can calculate theta is equal to so omega 0 t plus half into alpha t square. Omega 0 t plus half into alpha t square. So in this case we calculate that final is at 10 pi omega 0. So omega 0 initial velocity is minus 4 by 6 into t half into alpha. So half into alpha is a alpha value is a 0.35 into t square. So what you got is a 10 by 31.4 is equal to minus 4 by 6 into t plus 0.175 into t square. Therefore that we change this one 0.175 t square minus 4 by 6 t minus 31.4 is equal to 0. So t you can calculate. We calculate that a square plus bh plus b is equal to 0. In this case, a is equal to minus b plus or minus square root of b square minus 4ac by 2a. So this is quadratic formula. So therefore, the t calculate the b is a minus into minus 4 by 6 plus or minus square root of the 4 by 6 minus 4 by 6 square minus 4. A is a 0.175 and c is a minus 31.4 divided by 2a. 2a, a value is a 0.175. The t value you can calculate, t is at 32 seconds. The t value is at 32 seconds, we calculate. So this is for the answer for the A. Then the answer for B. Between t to 32 seconds, in this case, between t equal to 0 to t equal to 32, so acceleration is a minus 4.6 radian per second square. So this is the deceleration. So this one will stop it. And then, how long taken to stop the thing? So in this case, original omega 0 is a minus 4 by 0. Final omega is 0. So you have to calculate the t. So t can be calculated omega minus omega 0 by alpha. So final is 0 minus 4 by 6 divided by alpha is a 0.35. So by solving this one, 4.6 divided by 0.35. So this is the 13 seconds. After 13 seconds, this ratio will stop. So this is for the we calculate for the angular acceleration program.